this question is about differential equation. In a certain chemical reaction, the amount x grams of a substance is increasing. The differential equation satisfied is solve. Okay, so when we're solving differential equation, the first step is to separate the variables, everything with x on the left, everything with x on the right. So we do that by multiplying or dividing by something. So here we multiply by dt to cancel out, and by x to cancel out. So on the left we have only 1 over x dx. This is what we get. And on the right we have k times this dt. Alright, so the next step is to integrate both sides. So we have to integrate. So for the integral of 1 over x, just look at the mf19, we get ln x, ignoring the modulo sign. And for the integral of k e to the power of, we use this. So we get e to the power of exactly the same thing, divided by minus 0.1 because of the chain rule. So we're done with the differential equation because this is the general solution, but now we have to find the value of c using the boundary condition. So here x equals 0 at the start. At the start means when the time is 0. So we replace the time with 0 and replace the x with 20. So what we get is, this is e to the power of 0, which is 1. 1 divided by minus 0.1 is minus 10. So c is ln 20 plus 10k. So now that we know the c, we have the particular solution. So we replace this c with ln 20 plus 10k. That is the value of c. So this is called the particular solution. So question is to just solve obtaining a relation. So actually you can stop right here, but this is like ugly and not simplified. So you can just use minus 10 instead here, and you get the final answer in the simpler form. The next part is, given that x is equals 40 when t equals 10, find k, value approach. So replace the x with 40, replace the t with 10, and we can find the k. So here, if we multiply, 0.1 times 10 is 1, and then we can factor out the k. So we have k times, we still have minus 10 e to the power of minus 1, and we still have plus 10. So we factor out the k, and we can move this ln 20 to the left. Now when we have a subtraction, ln minus ln, we can combine it into a division. 40 over 20 is 2, and then we divide both sides by these brackets. So we get the value of k in exact form. Question is to find value approached by x as t becomes large. So t becomes large means when the t is infinity. So this is the original equation, and then we replace the so from the original equation we can again factor out the k. So here we still have minus 10 times this, and we will have plus 10 because we factor out the k. Then we replace the t with infinity. Okay, so this is what we need to analyze. What is the x when the t is infinity? So when the so this is as t approaches infinity actually. So I mean as t. So as t approaches infinity, minus 10 e to the power of minus 0.1 times infinity. So the trick to use the calculator is to replace the infinity or the t with something big and positive, such as 99999 or something. If you get a math error, you use too many nines, just use fewer nines. Okay, so you just plug in something big for infinity. Now if you use your calculator, you'll get 0 or something approaching 0. So this is 0, which means we can replace all this thing with 0. But remember, we already know the k. This is k, so we replace the k with what we have found before. So this is just 0 plus 10, which is 10. So for the final answer, we can do e to the power of both sides. On the left we cancel out, we have only x. So e to the power of everything here is the value approached by x. Use a calculator and you should get 59.9 in 3SF. Alright, that's it. I'll see you again next time.